All right, 23 was another sneaky snake. It says the coefficient of x squared in the binomial expansion of 1 plus 3x to the n is 495. Determine the value of n. I don't think we've ever seen a problem before where n is unknown. N unknown is a pretty tricky one, but that's okay. You're smart. Here we go. I am honing in on one specific term, right? The coefficient of x squared. So that means I'm going to begin with the formula. Okay, and we know the coefficient of x squared is 495. Okay, so what are all the things that contribute to x? Is exponent. Just right here, r. Okay, so let's use that to figure out r is 2. So I now have n choose 2, and then 1 to the n minus 2 times 3x to the 2 is equal to 495x squared. Well, I can kind of ignore this because anything to, or 1 to the power of anything is always going to be, it's always going to approach 1. So I can disregard this because this piece of information does not help me in solving this problem. So instead, I have n choose 2. I can distribute the 2, or the exponent of 2 rather, to the 3. I can also distribute it to the x. And I'm sort of getting somewhere here. I'm going to erase this for space. We know that r is 2. We found it out. So now I have 9 times n choose 2 x squared is equal to 495x squared. Okay, I'm getting there. Let's divide both sides by 9. I now have n choose 2 x squared is equal to, let's do 495 divided by 9. 495 divided by 9, 55. Cool. Is equal to 55x squared. Now I wouldn't want to divide both sides by x squared because that's mathematically incorrect. That would be eliminating a possible answer choice or a possible solution to this equation, right? If x squared is on both sides, x equals 0 would be a solution, and we wouldn't want to just divide both sides and get rid of the x squared. But for the purposes of figuring out what n choose 2 equals, we can disregard these two pieces here. We are now left with n choose 2 equals 55. How do we figure out an unknown n over there? Well, let's go to the formula for n choose r, and maybe that will help us, okay? NCR is equal to n factorial over r factorial times n minus r factorial. I have n choose 2 is equal to, I'm just subbing in my known stuff now. I don't know what n is, but I do know that r is 2, and I do know that n minus 2 is down here in the denominator, okay? So let's try to figure out this whole piece here. I have n choose 2 is equal to n times whatever came before it, 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 onward and onward forever, to infinity, right? And then I have 2 factorial, which is just easy, right? And then let's think about what n minus 2 factorial looks like. That would be n minus 2 times the number that came before it, times the number that came before it, onward to infinity. Do you notice that as we keep going, this will cancel, this will cancel, this will cancel, and if we keep going on infinity, 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 these will just keep canceling. This is called cardinality in sets, when items in a set match perfectly with items in another set. Take, for example, -1, or here, let's take, for example, the set of all positive integers. Let's write it like this here. Oh no, don't freeze. Please don't freeze. Please don't freeze on me. Oh, please. Okay. Let's take, for example, the set of all negative integers. I don't know, -2, or it would be in the reverse order here. Yeah, we would do like -4, I don't know, -3, -2, -1, dot, 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 right? And then think about the set of all positive integers, right? It would be 1, 2, 3, 4, dot, 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 right? This cancels this. Stop. This cancels this. This cancels this. This cancels this. This cancels this. If we keep going in either direction towards infinity, these two sets of numbers have cardinality. They directly cancel one another out. That's exactly what's happening down here with all these factorials. What are we really left with now? We have 55 is equal to, right? 55 is equal to n times n minus 1 over 2. I now have this over 1. I have 55 times 2, right? We can cross multiply. That's going to be, actually, I'll just put that here then. 110 is equal to, and then I have n distributed would be n squared minus n. This is quadratic. Yahoo! Sorry, this is, boop, boop. Okay, and then this would factor to n minus 11, n plus 10. Yep. Then I have n minus 11 equals 0, 0 product rule, n plus 10 equals 0. I now have n equals 11, and n equals -10. I would reject this because n has to be a positive number. That's just the nature of combinations, and my answer would be n equals 11.